Available light is only part of the story. With live video, the brightness control will adjust a brightness set point for auto gain and exposure control processing. In a still image, the brightness control digitally adds or subtracts an offset from image RGB values. In the next slide, we will examine a graphic that shows the combination of components contributing to brightness levels. This block diagram shows the pieces that make up brightness and contribute to image brightness levels. Moving from the left, we see the tip optics, camera optics, and camera sensor. Moving further right, we can see the light fibers and image harness running throughout the insertion tube. In the probe pod on the far right, you see the electronics that do the processing required to deliver an image and allow for the image transforms that can help provide increased image clarity. Our RVI business has been refining this optimization for close to 42 years. Mentor Visual IQ, this powerful processor, is the latest in this evolution and has more capability in this area than any borescope available in today's market. Here we have an example of how optical tips play a part in achieving brightness levels. There's a factor of 18x difference in brightness between the tip on the far left and the tip on the far right. This is very tied to the near depth of field, or DOF. In general, the brighter the tip, the further the near depth of field point. As an example, the gray tip is much brighter than the black tip, but trades off some near depth of field to achieve that result. The Mentor Visual IQ HD sensor will receive maximum benefit by using tips with higher brightness levels. Let's take a look at how brightness is controlled on any given target for inspection. With the camera close to the target, as illustrated on the left side of this chart, we have lots of light, so short exposure and minimum gain. As the camera becomes further away, the system regulates exposure and gain to maintain brightness levels. First, exposure increases up to a maximum of 1/60th of a second, and then gain increases up to its maximum limit. Beyond that, the image begins to get darker. On the next slide, I will show how this increase in gain affects the image. As gain is increased, color and edge enhancement is reduced or suppressed. This is done to keep noise levels manageable. The top image shows a typical image created by a video borescope. The bottom image is an example we created to show what you would see if we did not reduce the sharpness and color to reduce image noise levels. Note how noisy the lower right image is.